Hello, guys. Welcome to another episode of CUDA Education. All right, today what we want to do is just finish off our our list of items that we're doing for laying the foundation to show our bistro scene. So we're gonna finish off all of the steps to do that, and then hopefully the next episode after this, we start to show some kind of bistro scene. Right now, we're just showing the triangle that we have been showing for a while. For those of you that might be new to the series, the Clean Slate series, and what we're doing, basically we take a fresh Xcode project. Xcode is the GUI, the programming interface for the GUI for programming metal. We take a fresh project, blank project, and then we build it up to eventually get to the modern renderer example. And it's a very advanced and sophisticated computer graphics scene application, if you will, that shows a bistro, right? So I took a blank slate, a clean slate, a blank project, and we're building it up to this advanced example. It's called the modern renderer. It's called modern renderer, and it's on the Apple Metal sample code library. So if you Google Apple Metal sample code library, you will be able to get you'll be able to search for the modern renderer application, and you'll kind of see a picture of everything. But right now, we're working our way, and we're still at the triangle stage. But hopefully, as I said, by the next episode, we'll start to see at least a framework of the bistro scene, right? Or something that's a little bit more special than the triangle. Okay, so yeah, we're just gonna work through basically all the way from 6 to the end, and we will yeah, and then we'll move on from there. So okay, step 6 is AAPLTextureManager.h. Okay, plus TextureManager.mm main texture heap management manages a pre-allocated GPU memory heap for all scene textures. So init with device, do we have that here? It might not be in the header. It might be in the actual file. So init with device, this guy right here creates an MTL heap of the configured size, 1.5 gigabytes. All textures are allocated from this heap rather than individually, which is more efficient. So that's init with device. This guy right here. Add textures, data, max texture size. It's a lot going on here. Okay, so line 400. Adds textures to a pre-allocated heap, decompressing the data from the data block. So what does it say? For each texture, create an MTL texture on the heap. Decompress each bitmap level from the asset data into a temporary buffer, then blitz to GPU private memory. So that's this guy right here. And this says adds textures to a pre-allocated heap, decompressing the data from the data block. So that's all of this right here. And we have some logic for if we support sparse textures and all of that stuff. Where is the closing bracket for this? It's a lot of stuff here. All right, the closing bracket is here. So from 400 to 532. Let's look like what it's all about. So that is the add textures data max texture size. All right, make resident for encoder. So let's look up that. Make resident for encoder. So this is calls use heap to make all heap textures available to a render pass. So encoder use heap, and that's this guy right here. Calls use heap to make all heap textures available to a render pass. Calculate min mip. Okay, so that's this guy right here. Calculate min mip, sorry. Determines the course's mip level to load based on a maximum texture size constraint. If textures don't fit in the heap, the system progressively reduces max texture size until they do. With use texture streaming equals 0, most of the complex streaming code, background loading threads, MIP request queues, sparse texture mapping, is compiled out. The textures are simply loaded in full at startup. Okay, let me see, use texture streaming. Well, let me see if there's other mentions of it. So use texture streaming. Let's see if there's another mention of it. Okay, it's a lot of mentions of use texture streaming. Okay, all right, so now we go to AAPLMesh.h and AAPLMesh.mm. GPU buffer creation. So let us dive into that. So as you can see, guys, it's a lot of files. Things are generally organized, but it's a lot of, it's very fragmented. It's compartmentalized, which is a good thing or a bad thing depending on how you're how you like to organize yourself. So AAPLMesh.h, AAPLMesh.mm, GPU buffer creation takes an AAPL mesh data and creates GPU ready metal buffers. So abstract, header for class storing data to draw a mesh including vertex buffers, submeshes, materials, and vertex chunks. Let's actually just look through it for a second. Okay, vertex data decompression uses the block callback uncompressed data to decompress directly into MTL buffer contents. Creates 6 buffers: vertices, normals, tangents, UVs, indices, chunks. Non-unified memory path. So on Intel AMD Macs, which have separate CPU GPU memory, the buffers are first created in shared memory, then blit copied to private GPU memory for faster access. CPU side metadata also decompresses material, mesh, and chunk data into NS data for CPU access, needed for calling, material lookups, etc. Texture budget fitting iterates max texture size downward until all textures fit in the heap. Copy with zone allows shallow copies that share the same GPU buffers, used for shadow pass copies. So that is AAPLMesh. All right, let me see if I could find. Okay. Okay, so you can see this if statement is testing if it has unified memory. And that's this guy, non-unified memory path. On Intel AMD Macs, which have separate CPU and GPU memory, the buffers are first created in shared memory, then blip copied to private GPU memory for faster access. So that's all of this guy right here. See. All right, copy with zone. All right, so this is copy with zone. All right. And then I guess this is a scene asset. This is a file, bistro.astc.bin, the scene asset, 309 megabytes. The compressed binary containing the entire Amazon Lumberyard bistro scene. All geometry materials, ASTC compressed textures for Apple Silicon. I guess at some point we'll get to this file. Maybe I'll show you on the system or whatever. But that's the main file that sort of has everything that we need. The main asset, if you will. Again, guys, in computer graphics, computer simulation, all that stuff, any kind of scene creation. A lot of the money is spent in creating assets. So asset design and asset creation and asset modification and asset enhancements and all that stuff, right? 3D models, all that stuff is because, it's very expensive to do well. And that's kind of what this is right here. So it's a scene asset. And then build setting change. You manually add L compression to other linker flags, both debug and release, to link Apple's compression library used by AAPL asset.mm. So Yeah, this is something that I had to do manually. I had to add a dash L compression to the settings in Xcode. The other linker flags setting in Xcode in order to get things done. And then for what it's worth, I do have this thing right here that shows sort of the layout of the land, right? I'm not in a position to really appreciate it right now, but it is what it is. We have our APL config file, shader types, mesh types, APL asset, and APL mesh. That's kind of the critical main logic. We have the camera that loops in here. We have material and APL common. That gets connected through AAPL asset. We also have AAPLTextureManager, and then we also have and that also gets looped into AAPLMesh. Well, Texture Manager, I guess, takes into account APL common, APL material, goes to APL mesh, and then the APL material also goes directly to APL asset. So, for whatever it's worth, guys. But yeah, this is so this is the end of the upper level step 5. So no existing code calls any of these new files yet. They're all infrastructure waiting to be wired up in step 5. So step 5 is the upper level, the higher level step is step 5. And we are going to move to that step next. And that's going to, hopefully we see something special in our bistro scene. I'm hoping that it's not a complete, everything is filled. Because, the next step is step 5, but we actually have 16 steps. So there's a lot more work to be done, and I want to progressively see the improvements in the scene. So I much prefer a shell of a scene, and then we slowly add things to improve it so that we can learn and understand how everything works together and becomes the full application. Sorry guys, it's been a long day, so I've been yawning all night. But anyway, guys, thank you for watching. This is Kuda Education. You know the deal. Support the channel, all that good stuff. Have a great day.